Hi, welcome back to another video with myself, Angela McCall. On this second video, we are going to be looking at Chapter 2, the Upward and Onward, as it's called, on the actual tutorials that are on the Solar2D website. So, if you haven't been here before, please be very kind, click the subscribe button and obviously hit that bell to stay notified for when I publish new videos. So let's go straight into the tutorial. Okay, so as you can see, we are going to start by loading up the tutorial, Chapter 2, Upward and Onward. This first section here is just telling you about how to sort of conceptualize, before you start anything, a plan of attack and create yourself a design document like you would if you get a design brief for designing a logo or something like that. So we don't need to worry about that too much right now because obviously they've done a lot of this hard work and the planning for us. So essentially we can go straight into the project setup. So they want us to open the simulator, create a new project. We're going to call it Star Explorer. It's going to be a blank template in the table preset form, and then we're going to click on OK. So let's get my screen sorted out for you. Okay, so we're going to start a new project. We're going to call it Star Explorer. I'm just going to put my Star Explorer app because of the things that I get involved with. We've got a blank template. We are going to change that to a tablet preset, which shows you the width is 768 and the height is 1024. So that's your portrait orientation, or upright as they like to call it here. We know that it's going into my Corona projects because that's the default. As a programmer, I actually use a different location and a different setup, but you guys go with Corona projects for now while you're getting to grips with things. And once we're all happy, we're going to click on OK. The next thing that's going to happen is you've got various windows popping up here. So we have got, let's get rid of that one. No, right, okay, so let's sort my screen out here. So that's the actual simulator, so that's whatever we design will pop up there. You also saw down here my files and folders. This is going to be useful in the first part of the video with regards to organizing our content. That's the folder where all of our app documents need to live within, and there you go, you can see it inside the Corona projects. We've also got my Visual Studio window just open up here as well, and as you can see, the My Star Explorer app showing, and again it's almost showing you all of those same folders down there. Okay, and I'm just going to stretch that screen so we've got more space, and we've got our main Lua code file that we're going to be using, as well as some of these others in just a short moment. And we've also got somewhere around here the Corona simulator console. This basically is the brains and everything that's going on behind the scenes. If we need to do any bug fixing or testing, this is where we can send ourselves messages from the code to sort of work out what's going on behind the scenes. So we are pretty much ready to go right now. Let me just see if I can just close this a little bit. There we go, move it out the way. There we go. Right, so we're ready to go. First thing it's going to ask us to do in our code here is settings and configuration. So in addition to a main Lua file, there are two other important files, which is called build settings and our config Lua file. Okay, so we're going to start off with the build settings file. We're going to open it up and we're just going to double check that the settings are the way that we want them to be. So don't forget, when you have a mobile phone device or a tablet, you can turn it upside down, you can twist it. You're used to doing things like that while watching YouTube videos or Netflix, and as you reorientate things, images resize and the video and the content resizes. This is basically how we allow or permit or deny those kind of things happening. So all it's saying here is the orientation is in default mode, which is portrait, and it's definitely supporting the portrait orientation, as it were. So it's nice, it pretty much does what it says on the tin. So let's go back to our code. I'm just going to drag this over again. We can see our build settings file here, and you can see that I've just opened it. And then there's that orientation. You can see it in the corner behind the screen there. Those first two lines that I've highlighted are comments, and I'll explain that in just a second. But then if we check lines 12 and 13 out, obviously it's one adrift on the lines here, but essentially everything is exactly as it needs to be. So whilst I have this open, before we crack on with any more of the tutorial, it's worth noting how the screen is laid out right now. What we have going on here is a nesting or an indenting process, because we can put code inside of code inside of code, or like bags that you'd put inside a bigger bag, inside a box, inside a container, etc. Same things happen, but obviously the computer can read this and make heads and tail of it really quickly, but as the human, we like to be able to visually present our code so that our eye and our brain can work out where the code belongs to what parts of the commands. So everything starts on the leftmost column. I think if I quickly just check, my Visual Studio settings is to 1, 2, 3, 4 spaces as a default indent. Some people use 3. You can take, if you dive into the settings somewhere, you can change that if that's not your particular liking. Works fine for me. And then basically what we've got going on here is where we've got 2 dashes. That's basically saying I'm going to put a comment. Don't use that as part of the main code to execute. Then we've got a variable, assigning it the content, and so basically, so the computer knows where it starts and finishes, we have an open and closed curly bracket. Now, if you look here, we've got an open bracket, then another variable, and then another open bracket. And down here, you can see there's a line all the way to the bottom, just where my text is, and that is how we close a bracket. So anything inside between that open and that closing curly bracket is all to do with the settings variable. And then in here, we've got an orientation variable, which is assigned anything between these 2 curly brackets. When we finished with these settings, we put a comma to say, hang on, we've got more coming. And then we've basically got an Android setting, and then we've got curly brackets for its content, and it also has nested within it other variables and so on. There is no limit to the number of infinity type levels of nesting, and the more complex your code, the more complex your games and everything that you do, the more complex your indenting will become. There are coding concepts to get around that and do things to make life a little bit easier, like functions, but essentially this is how you lay out your code. So anyway, we're happy with all of this. I'm going to save and close that. So let's go back to our Lua file. Oh, there we go, main Lua. And you can see now main Lua is in the top of the screen as well. So I could, if I wanted to, jump between them. Okay, right. Okay, so we are here. Let's have a look. So that's just basically explaining the orientation, which is fine. Now we're going to look at the configuration file. So this is where we get to configure some specifics. Now, in here, we've got the width and the height, which it will have picked up automatically from when we created our file. That's fine. But there's also something called scale. And that basically talks about, if you've ever watched Netflix and you're watching a video but your phone happens to show you like there's black bars on the side, that's because the actual content area of the video is a slightly different shape to the actual screen size on your phone. And so it might have cut off a little bit of the right and the very left of your video. But you can often hit the zoom button and it will fill it up a bit better, at which point you might find then it fills to the top and the bottom and nicely to the edges, but then you're missing a bit at the top and the bottom. So basically they have a terminology to call those 2 different settings because people can change them between their own preferences. Letterbox is a lot more shorter in height and a lot wider, at which point the device represented by that red dotted line will mean that the content on the very left and the very right will not be seen by the user. But likewise, if they was to expand it, they would see the very left and right edges, but then it might mean that the top and the bottom of the video or the content area will be cut off. Now, if we go back up here, where it's talking about the width and the height, at the moment I am using, we've got the phone set to a view or as a an iPhone X. Obviously we've set this up as a tablet, so really I should change this orientation to be something like an iPad Pro. Okay, which means obviously my screen's a lot more congested right now. So that's something to bear in mind. I'm just going to put that over to the side so we can start moving it back and forth. All right, so this is more like a squarer 768 by 1024 in height. But then obviously every tablet designer out there will do something just a little bit different, and so we have the power to control how the device automatically loads and what it will and will not do. So we set this in the configuration file, so it's called config.lua. So if we pop back to our code over here and we just drag this open, there's our config.lua file. It's just opened up. There's the content, 768 by 1024. It's already found out that it's going to be letterbox, which has done it for us. It's got some code commented out, which is fine. That's for us for another day. And then finally, frames per second, just like any videos that you watch, however many kind of, almost like, think of it as like photographs that you get to see in the space of 1 second. Every one of those photographs is a frame, a bit like a flick book, and they're going to show 60 of them in a single second. The higher the number, the better the quality of the video, which means the human eye picks it up as a seamless video sort of experience. You might have something as low as, I don't know, 20 frames per second, at which point you might see it feel like it's juddering a little bit, like a robot as the image moves, because there's not enough content to make it seamless. But that's basically what's going on here. So we're all good with that as well. So these just here basically explain the what the scale means and the letterbox, basically everything I've just said in a little bit more detail. Now they've asked us to change the setting to zoom even, so we are going to go back to our code. Let me close that config. We're going to change it to zoom even, save, and then close. Right, okay, we're good. Right, now we're going to get to the actual game itself. Now, just like we did the balloon tap, we're going to do most of the code in the file called main.lua. All right, and then when we start that file up, we're going to put in these first 3 lines of code. So quickly talking about these, we're going to bring in the library, which is the physics engine. So that's all of that code that talks about gravity. We're going to start it straight away. So just like you start the car engine, it's going to be there, and then we're starting it. And then we're going to set the gravity to 0, 0. All of this explanation down here is basically saying that don't forget, when we was doing the balloon, we could move the balloon left and right, which was the first number, that's the x-axis, and obviously 0 means it doesn't go anywhere. And then obviously the second number was the v, or the vertical axis, y-axis, sorry, going vertically up or down, and we was tinkering with it to make the balloon go up only. Well, in space there is no gravity, so a way of us setting that the physics engine, so things can still bounce into each other, they can still collide, they can still move around the screen, but they can go in any direction, means that we set a gravity here to 0, 0. So let's get this bit of code done as well now. So let me just copy that. Copy, and where is our code? Oh, I've lost my code. There we go. So main.lua, we're going to put the code there on line 7, paste. Okay, job done, save. Now obviously there's nothing to view just yet, so we're going to move straight on. Now this game is involving asteroids coming at us from the left, from the right, from above, and we're a little starship and we've got to like kill them and avoid them and all sorts. Obviously, that means that we've got to have objects being created and thrown at us. So what they're going to use is a piece of code called a random seed. It's basically like a kind of a maths calculation. And to start that, instead of giving it like the number 1 or the number 2 or something like that, it's going to use time to randomly create these objects. Now, obviously, when we're looking at time, time is continuously a number that's constantly changing every second, every microsecond. So the numbers it creates will create a seemingly random pattern, and we can code those numbers to represent different things. So in order to create the appearance of random asteroids being thrown at us, we're going to need to create or use this line of code just here. So they're going to ask us to put that straight in. Now the line of code on number 11 there is actually just a comment to ourselves to remind us what this is all about. So if you look where I've pasted it now, just like before up here in green, this code here is basically, sorry, this line of text here is in green. So it starts with 2 dashes. This is our way of telling Lua, Ignore this line. This is an instruction to a human to remind them what this is about. This is the notes in the margin of a textbook if you were in a school lesson. Okay, so that's basically where we're up to here, and I'm just going to save again where we are. Don't forget that little dot at the top means the file is unsaved, so we've just saved it. All good. Now that's the comments, right? So here, and that's the random number generation, which is what we've just explained, which is all good. Now we're going to need two objects. First of all, we're going to need to create or use the background image, and we're going to need some game objects, which is on an image sheet, which is what they're going to teach us about next. So we can download this from the source file. So we click on this, you can see my source files have opened up. I'm just going to extract it. Go up one setting, down, there's my downloads, and oh, where's it gone? There you go, getting started. There's my unzipped versions. Okay, so in here we've got that game objects PNG. Let me just move that up. That's the game objects PNG and the actual build, the background. So I'm going to just copy both of those, copy, and I'm going to go to my documents, back to my Corona projects, into my Star Explorer, and right in the main body of the app, I'm just going to paste those two. So now my two images exist for me to be able to work with them in the app. We did cover this in the first tutorial back on the balloon app. So if you need to just a refresher, go back and watch that. Right, so loading image sheets. Now, what you've got to bear in mind is that mobile devices and tablets, they don't have an unlimited amount of memory. And, you know, if you've got kids and an old phone that you've given them and they run out of space and they're forever moaning, you're going things like, delete some photos, delete some videos, because it frees up some memory. So when we're building games like this, obviously images, they use a huge amount of data, and that data has to live somewhere in the phone memory or the device memory. And so whatever we can do as programmers and designers to minimize how much data those images use, the better designers and developers we are. One of those techniques is to create one big image as a sheet. So think about it as a piece of paper with lots of tiny little images on it, and then we tell coordinates to the phone how to find each of those individual images, and that's what an image sheet is all about. Now they can be a bit fiddly to manually create. There are tools out there that help you do it. They're suggesting here there's a company or a site called Texture Packer. Go investigate if you get that far. That's how you can go and create these image sheets and save some memory, but obviously they've already created this sheet for us. So what are we going to do? The next thing we're going to do is we have to tell our app about this image sheet existing and how to find the information on it. So lines 14 to 21 is where we start that process. So I'm going to copy that, and I'm going to stick that on our code as well. So lines 14 to 17. So again, a little note to ourselves in the comments, starting with 2 dashes, a local file. We covered this in the first video, but this means that this variable sheet options only exists within this main.lua file. It cannot be found by any other file in the game or the app. Then we've got an equal sign, and then we've got an open bracket telling us where this variable starts and where the code for this variable ends. And inside this, we're going to put other variables. Now, technically, this is a special type of variable because it's actually a table. Okay, so whereby before, when we've done other things, we've created one variable and it's had one object inside, we can actually create one variable that has multiple objects inside. And to store that information, we have to create an invisible table so that we can structure how that information gets stored in the variable. And we do that using these curly brackets to tell where each section starts and ends, just like we saw a moment ago in the build settings file. Okay, so what we've got going on here now, it's basically, if we move this down so you can see it above me, we have got a diagram here of our image sheet. So our image sheet has 6 images on it. The first one is the main asterisk, which is 1, 2, 3, 4 versions of the asterisk. We've got a light beam, and we've got the starship. So on one image, we've got 6 little frames that we have to tell the computer about, so it knows where on that image to save memory that these are. We could quite well make this as 6 separate different images, each with its own file name, and call each one individually. Nothing's stopping us doing that. The game would work just as well. The only challenge would be is that that would actually take up a little bit more memory in the device that we're going to be using this game on, and that's a bad programming practice. That's all we're trying to do, is save memory. So all they've done here is, if you look, each of these items has an X and Y coordinate. So X goes across, Y goes down or up, and then it obviously has a height and a width, or a width and a height. So each of these images has 4 bits of information. And if you look down here, oh, sorry, I was a bit too quick. We are literally just going to name first asteroid, second, third. Obviously, they haven't done a 4th one for whatever reason. Then there's our ship, and there's our laser beam. So all they've done is maybe just use 3 of those images and not the 4th one. We might find out why in a minute. Now, if you look at the yellow text, okay, it starts on line 19 to line 48. It actually starts with that being the first image, or the first frame, and that's the word, second frame, and it's being identified between an opening and closing bracket, and then putting a comma, just like we would in a sentence when we start the second part of a sentence, and then that's our way of actually showing the programming language Lua that these are the 4 bits of information per image and where to find them. So the coordinates basically just say where on the sheet of paper and how much the wide and height of each is. Then we close off the frames, which is what this one down here does, and then we close off the image sheet itself, which is this closing bracket down here. So let's just copy all of that to save ourselves a lot of work. Okay, so we go inside the frames bracket. I might just have to double check my brackets in a second. Right, so we've got frames, open bracket, that's fine. So line 19, there we go, you can see it side by side there. Okay, all is good. So asteroid 1, 2, 3, ship and laser. Now that's got a bit of skew here, so I'm just going to straighten out my code. As far as Lua is concerned, when this is read into the program, it wouldn't have had a problem, but as a human, we need to keep our code nice and neat so others can work with it in the future. And I'm just going to hit save. So we've just explained what that is. So all we're doing at the moment is doing a lot of prep work. Believe all of this code so far is still prepping us to get things on the screen and to actually design the game. Okay. Now we actually, now that we've kind of prepped this, as in like we've got a variable with all of these instructions, we actually need to create the image and bring it into the game itself. So at the very end, we're going to create an object now to hold that image sheet. So we're on line 51, and I'm just going to scroll up a little bit so you can see a little bit better. So we're going to create a local variable that lives within this file. This variable is called object sheet. It's going to contain one item, which is the file game objects.png. We're going to put that into a graphic as a new image sheet. So in the documentation, we'll find that in just a moment so you can see that. And instead of writing a list like you have on all the other variables and objects that we've created so far, we're actually just bringing in one variable that already has all of this information. So it makes our code a lot neater and easier to read. Now, if we quickly go to new image sheet, let me just go up to documentation. We could just grab that right now. Oh, I can't get my cursor. There we go. And copy. And I can type that in there. Paste. Now, when you do a search in Lua, it gives us loads of results, but it's generally the one that goes underneath the line. So this is the one that we want. And then there's our instructions. So a graphics new image sheet. It tells us it's a function, what it does, gives us a quick overview, an example, some things to watch out for, and then it starts showing us how the syntax, which is the way that the text and the commands are all put together, what they mean, and then it gives us some examples down here. Okay, so a simple image sheet was an image sheet we were doing, yeah, simple image sheet with some more complexities, and it explains all the different parameters and different bits of information that can be involved. So that's how you can find out more information. So let's go back here, and we are done with that. So in a minute, that will load. And now we're going to come down to initializing some variables. Now we're going to learn about initializing variables later on in a couple of other lessons. I have touched on it before in previous videos. What we're doing here, remember in the previous video when I spoke to you about how Lua is a linear programming language where everything gets read in from the top, and as you read it, just like you read a textbook, you learn this information, and therefore once you've learnt it, the information therefore exists and you can act on it. This is exactly what we're doing here. So all we're doing right now is creating a whole bunch of variables that can store information that we're going to use later on in our game. So by doing this at the beginning of the game, before we get into the nitty-gritty, it means that all of these variables are then existing to be used for other parts of our code to reference them and work with them later on. So we're going to create, all of them are local, so that means they can only be used inside this file. We're going to create a variable called lives, so we're going to start by giving it 3 lives to start with. So obviously we're going to count down every time we lose a life, that number's going to change. We've got a score, we haven't got any game at the moment, so scores always start from 0. Died, as in we're going to turn something off. So the easiest way of turning something off and on is to use a Boolean value, which is called false or true. So obviously died means false. There's our asteroids table. Again, it is a variable, but it holds multiple bits of information as opposed to all of these just hold 1 bit of information. That's why we've got a little bracket to say where that information starts and ends. At the moment, we're just saying the table of information exists, but it's empty, a bit like looking at an empty blank Excel spreadsheet. We're going to need a ship. We're going to need a game loop timer, lives text and score text for putting information on the screen of our game as well. So now these variables exist. We're also going to create a couple of other things. Now we're going to create things called display groups. Now if you ever watched like an old or played an old version of Sonic the Hedgehog, for example, or even Mario, or maybe something like Angry Birds, you've got the background scene that goes really slowly, then you've got the foreground where it's moving quite fast, and then you've got commands and scores and things on top of that. Okay, so it's almost like every game that you build or design is built in 3 layers. You've got the background, the foreground, and then you've got the user interface. Okay, in this tutorial, they've called this back group, main group, and user interface, UI. I've always called it background or foreground. You can create your naming convention the way that you want. I suggest you go with what they've done for now, so it makes it nice and easy. I'm going to do the same, but you will develop your own way and technique of doing things. So I generally use background, foreground, and user interface. That's how I get around it. So we're going to create these 3 layers so that everything that we do and create will live in one of those 3 layers, so we can then force the hierarchy of how things show on our screen. So let's come down here to line 65 and paste that. So again, you've got some little comments that are following after, and you've got a comment before. So we've got all of these are special types of variable. They all contain groups that are linked to the display, the screen of the game. So we've got our back group, our main group, and our user interface. They're all groups, so they all have the same commands, and they're just 3 different. So they are created in the order that I want them to be built. So I start with the background, then I layer on top the foreground or the main, and then I put the user interface on top of that. Remember, we talked about how the order of things can play a big part in what you see on the screen in the previous video that we did when we did our balloon tap. Moving on down now, there you go, there's a quick note on about how the order is really important, and it's about stacking those orders up. So we're actually going to start by putting something on our game screen right now. So let's start by loading in the background. So let's quickly talk through this. First of all, we're going to create a local variable called background that's going to contain the image of our background. It's an image, a new rectangular image, which is part of the display library. It's going to live in the background layer of our game. That's the file name, so we know what image we're putting there, and that's the size in width and height. So Once we've created it, we're going to center. Remember, everything's 0, 0 in the top left corner, but actually we want it to start working from the very center of our screen because we don't know how big the screen is. So by starting in the center and working out, we've covered all our bases. So therefore, on the display, we're going to put it in the center of X, which means somewhere between the left side and the right side in the center is where we're going to position our image. And we're going to put it content center Y, which is somewhere on the Y axis, somewhere between the top and the bottom. We're going to find the middle and we're going to put the image there. So I'm just going to copy all 3 of those commands. So I'm just going to copy all 3 of those commands right now. In fact, I'll take the comment as well, so it's nice and clear for you. Copy. And I'm putting that on line 70. So you can see that we're starting to do a scroll now. There's a lot of text going on here. So that's our object, and we're basically telling it its X parameter center on the screen, its Y parameter center on the screen. Now, loading the ship. Okay, so as earlier, we're going to create a ship object. Okay. But the ship lives on that object sheet somewhere up here. There it is down here. So we have to do this in a slightly different way. It's not a standalone image like we've used before. So we are going to take that line of code and we're going to talk through it. Copy. And right now, first things first, up on line 60, we have already declared the variable existing. So by putting local ship, we've already told the computer program we're going to use a variable called ship to house our ship. The size of it, the image, the dimensions, its name, any other characteristics we want to give this ship is going to live in this variable. Therefore, when we actually go now to populate this variable, we don't have to use the word local again because we've already done that part of the job. So whereby up here we hadn't used, we hadn't used a variable yet called background. We declared it all as a variable in the same line. We don't need to. We can just crack on by using this ship variable. So again, a new image rectangle. It's going to live in the main group or the foreground this time. We're going to grab it off the object sheet, which obviously has been populated already up here. So that's our object sheet, which holds the thing, and that's its instructions to know where all the frames are. So we already have all of that coded in, and what we're going to do here now is we are going to position it on screen and tell it what of those frames it is. So if you look up here, it says frame number 4, ship number 4. So that's what the number 4 is. So that's the frame. Then we're going to put it the width and the height. So we're not going to change basically the size of the ship image. Copy. Oh, we've done that bit. Right. Okay. Save. So there's the first parameter, says it's 4, and there's the width and the height. Okay. And obviously it's just reminding us where we declared the ship variable. That's the reference to it. That's fine. Okay, now what we can do now is overwrite any of those things that we want or give it some more characteristics. So coming in here, let's talk about the extra characteristics this ship's going to know about. Well, we are going to want to put it in the center of the screen again, and this time we're going to put it at the bottom of the screen. So content height, we'll look at that in just a second, but that's the height. It's a command that basically tells the Lua programming language how tall our screen is, and from there we're going to say go to the very bottom, or that's the full height minus 100, so we don't forget anything in a minus number is moving north. Then we are going to add physics to the body, just like we did the balloon. We've got to tell where does the ship start and where does it end. So when we tap on it, we know we're actually in the ship and not tapping somewhere randomly out in space. There is a more accurate way to do this because obviously the ship is a triangular shape in our image and we're just going to use a radius, but we're going to cheat for now and just do this as a radius 30, and we're going to tell it to listen, or it's like a sensor. So the ship now knows that it's got to be sensitive for when people touch it. And we're going to give it a name. We're going to call it ship, aren't we? Nice. Okay, so let's have a quick look at where we are at the moment. So this is the game at the moment. So our background has loaded, but obviously because we hadn't yet told it where to go, it's put it up in 0, 0. And if you look at it, it's the actual very center of the ship. So although images and content gets put in the app in the top left corner, they position them by the location of the very center of the image and the object. So that's why you haven't got the nose of the ship showing or the left-hand side of the ship showing. So let's now save this. There's our little dot to say we haven't saved the file. And as we do so, you can see now it has repositioned it on screen. So let's see if I can move my screen around a little bit more so it's easier for you to follow what we're doing. Let's move this over here. Okay. There we go. Oh. Okay. So we are back to this place now. Okay. So there is our ship. Now, the next thing we have to do is we are just setting up our game still. So as you can see, they want us to put into the user interface group some text to count the number of lives that we've used before we've hit an asteroid and what our actual game score is. So again, I'm just going to copy this and we're going to talk through this. So again, we created text in our balloon app. So it's a similar concept to what we've already done, which is why I'm speeding through it. But we are creating our two variables. We're now populating them. So we created them already on the reference for these objects to live in. There's our live text and there's our score text. We're putting from the display library a new text object into the user interface group. So the very top layer. So it sits above any of the asteroids. So when the asteroids come on screen, it doesn't suddenly hide our text. So the text is the most highest thing out of those three layers. We've put here, now this is a little bit of concatenation, which is a special word used when we join text that we want to write on screen to some of the scores that are going to change. So we've started off by writing lives inside double quotes and then a gap space as you would normally before we write the number. But then we need to say actually the next thing that we're going to write on the screen isn't going to be text. It's going to be the answer of the variable that lives inside lives. And so by adding these three things together inside a comma, it kind of builds a sentence for us on the screen. We've got our location, X location, Y location, coordinates, the font name and the size of the font. So we're going to save that. And there you go, you can see it popping up on screen right now. Okay, and you can fiddle around with these if you wanted to. I could say 100 and then you'll see it move over and you can say that side maybe has to be 500, for example. And you can move things around. You could change the text size to 50 and then it's going to get really big and so you can have a play and get used to things. Okay, now because this number is 80, which is a positive number because there's no minus sign, it means we're taking it from the top of the screen and we're moving it down so it's a positive number. Again, we've covered that in the coordinates before. And again, it's a positive number, 200 from the left-hand side and 400 from the left-hand side. So don't forget, everything is based on that top 00 coordinate location. Okay. Next thing we are going to do, we've now got to, let's have a look. Now our status bar isn't showing on our simulator, but it does want us to hide the status bar. So perhaps different devices might work or respond in different ways. So we are just going to add that line of code in. That's fine. So I can't really show you that because it's not really. Oh yeah, there it goes. My bad. So if I take that out and comment, you can see at the top there it's mimicking time, how much battery, etc. But we don't want all of that nonsense covering up the quality experience of our game, so we're just going to hide it. Save. It's very tiny, so that's why I didn't see it, so that's all good. Hiding the status bar and then coming back down here. Now we're going to create a function so that these numbers and scores and lives update as we play the game. So let's start, and again we did this similarly with the balloon tap counter in the previous lesson. So, okay, there we go. So again, because this is a function which has a start and an end and everything that lives inside it therefore is then indented. So in our variable, we've put the text in. When we created it, we gave it text already, but now we need to write over that text with the new score and the new lives. So we have to refer to it with the dot text there. So we're saying with that placeholder variable, and we're specifically accessing the text parameter, we're going to overwrite it with the word lives and whatever the new count is. Okay, so don't forget these two variables are going to hold a number. Okay, we started off by telling it 3 and 0, but that's going to change as we play the game. All right, so whenever we say update text, it's going to put the newest version on screen. So that's how we update the actual visual clue to the user. And that's where we're at to on here. So we haven't actually done anything to actually play the game just yet. We've just literally been creating the environment. All of the concepts that we've been discussing so far are actually listed here. So that's where you can learn more about that random seed, the image sheet, and the grouping concept that we talked about earlier on, and hiding the status bar. I think the one to look for that's quite handy as well is this content height, because it says here it's only a property that you can read in, so you can't really do anything with it. You can't change it. You can do maths to it, but you can't alter the original result that it gives you, but it basically gives you the height of the content area. So every device will have a different content area, and that's how you can then learn how tall the screen is and place the ship just 100 units above the bottom of the screen. That's how we do it. So there we go. I hope you found that useful, and we'll see you on the chapter 3 in just a moment. And don't forget, make sure you subscribe to my channel. Thanks.